Hello, my dear learners. Uh, Today we are discussing the next part of machine learning. Uh, we'll start with another definition of machine learning. Here, the goal of the machine learning is to develop methods that can automatically detect patterns in the data. So, in the previous lecture, we also discussed about how the data is enter in the machine learning model and different patterns we can analyze from that particular data, and then used to uncover patterns to predict the future data or other outcomes of the interest. So we also discussed various examples also, to predict whether the forecast of the today, weather forecast of today, if that rain is coming today or not. So through the previous available data, we can find out the prediction. Now, here we are trying to learn about the various key terms while we are using the machine learning. The various key terms are there. The first one is the features. So what are the features here? Features actually, when we are providing the data, though with the columns of the data in the data, the input set is called a feature. So one column is a one feature. Okay, so multiple columns has a multiple features in them. For example, for an instance, if you're trying to predict this type of the pet someone will choose, okay, then your input might be include like age, home region, family income, etc. Okay, so these are the some of the features in that particular data. And it also means that property of your training data means your data would contains different kind of features or properties. A feature is the input value you have to feed to the model or the system. For the example of linear regression, so we say the x variable is are called the features and y are the predicted values in linear regressions. Now move on to the next called label data, in which the output you get the from your model is called label after training. Okay, so the label is the thing we are predicting. For example, the value of y in this linear regression that I also already told you in the previous slide. So x is the input data, this is called features, and y is the output variable, which is called the label. Suppose we are giving the model to data like a person age, height, hair length, and then your model predicts whether the person is a male or female. So the male or female is the label to the particular data. So that we can predict on that particular data. Now, as an example, you can see in this, we have example number, color, type, origin, and the final result. So if we have features called color, type, and origin. So if red, sports, and domestic, then it should be labeled as stolen. If red, sports, domestic, somewhere it is also labeled as no, not stolen. Then red, sports, domestic, somewhere label are stolen. So yellow, sports, domestic, we have label as no. So we have here to predict whether the car is a stolen or not. So we have multiple data. So we can predict if, for example, we have a yellow SUV and it is an imported. So how we will decide? So you can see, match the particular data into it. So you can see in 6, 7, and 8. The here we have yellow SUV imported, yellow SUV imported, and yellow SUV imported. So three outcomes or three labels are coming here. So if we vote here, the maximum is no. The particular predicted value should be, answer is no here for yellow SUV and imported. So this is how you can predict the whether the car is stolen or not from the available labeled data. So what the features are here? The color is the feature, the type is the feature, the origin is the feature. And what is the label? The label is the stolen. If the color, type, and origin matches, then it will be the label to that particular data. Now we are ready to design the model. So how will we design the model, or what is model is here? So a model is a relationship between the features and the labels. But obvious, it is a simple thing, things to understand that what the model is. It is a input and output. Okay, it is a relation between input and output. So ML models is a mathematical model that generates prediction by finding patterns in the data. So ultimately goal is to predict something from the available data, and to predict we have to find the patterns in the data. Like in stock market, they are saying this particular stock will go up or down in the previous, in the today or future. So they will analyze the previous behavior of the data through the graphs and various kind of data analytic tools. So they can also predict that particular patterns, and through which we can predict that the stock will go up or down with respect to the data. Now the ML model generates predictions using patterns extracted from the input data. A model represents what was learned by a machine learning algorithm. Okay, means when we have to put the data to make learn a machine, so a model is, it represents that what a machine learning algorithm learned. The model is the thing that is saved after running a machine learning algorithm on training data and represent the rules, numbers, and any other algorithmic specific data structure required to make predictions. So in the previous slide, we also discussed about the features and labels. So now, when we have to running a machine learning algorithms on training data which represents rules, numbers, and any other algorithm specific data structures required to make predictions. Okay. Now this is the basic model where a data and algorithm which gives the machine learning model. Now, what are the basic steps in machine learning? Okay, so in the previous slide, as will say that we have machine learning, data as an input or as a machine learning algorithm, and it will provide the machine learning model. So here is the third step where we introduce the machine learning model. So before going to this machine learning model, we have to go through these two particular steps also, that is data collection, data preparation, and after that we have to choose the machine learning model for the particular specific application through which you can find the predictions, and using that particular data we have to divide the data into two parts called training data training data and testing data. Okay, training data, testing data. Generally 70-30 ratio is giving that we divide the data into the two parts, training data and the testing data. So using the training data, we train the model. Then we have to, once the model is trained, we have to evaluate the model using testing data. After that, we have parameter tuning, and after that we have to finally able to make predictions using that particular machine learning model. So these are the basic steps. Now let's take steps one by one. First step is the data collection. It is a process of gathering and measuring information from countless different sources. So in generally, as a researcher, we will take the data sets, we find the data sets or we create the data set. And generally, we can find from Kaggle and different various sources are also available through which we can get the data sets. Okay, so this is the first critical steps where you have to collect the data sets. Okay, it from various sources, as database, files, external repositories, etc. Before starting the data collection process, it is important to articulate the problem, what want to solve with an ML model. For example, we have to identify after the COVID what are the risks of predicting that multiple heart rate diseases. So we need the data of after the COVID, that how many number of patients get involved in the heart diseases. Okay, heart diseases. So we find that particular kind of data. Okay, rather in you have to find predict the stocks, so you need the stock data. So according to the need or according to the problem, you have to find that particular data. Next is data prediction. Once you get the data, you have to process it, pre-process it. Sorry. See, the pre-processing means we have to generally add, delete, or transform training data set into the normalized form, into the normal data. Since the collected data may consider undesired format, unorganized, or extremely large, further steps are needed to enhance its quality. So these are the three common steps we are using called formatting, cleaning, and sampling. Okay, formatting, cleaning, and sampling through which we can format that data, the unorganized data to become an organized data, and you can also do the scaling part also, so that extremely large data you can scale into the smaller one. So final definition comes as it is a process of transforming raw data so that the scientists are and the analysts can run it through the machine learning algorithms to uncover insights or make predictions or patterns. The next step is once you have to clear the data or identify which data you want to go to the model, you have to choose the machine learning model. So there are multiple machine learning models are available. For example, decision tree, random forest, linear regression, CNN, ANN, convolution neural network, etc. So multiple machine learning models are available. So you have to choose according to your problem which is more suitable to that particular application. So for different purpose, different machine learning models are available. So it is depend upon the need of that which machine learning you have must to be selected. The choice of machine learning model is selected depend upon the many factors like problem statement, the kind of output you want, the type, size of the data, available computational time, number of features, and observation in the data. It depends upon the problem mainly. Once you identify that particular machine learning algorithm is ready, the data is ready, then you have to put your data into two parts, split your data into two parts called training data and testing data. Now, generally, as I already told that the 70-30 ratio should be taken. So first you have to train the data using the training data set. So this particular step involves training the machine learning model with the training the data to learn from. Through the training data, your machine learning model will learn. Let's say that you want to train a model to predict if email is a spam or not. So you will provide the ML model while training the data that contains emails for which you know the target. That is a label data. Means you give the emails, multiple emails, and you have labeled it that this particular email contains spam, that particular email contains not spam, email spam is not spam. This kind of labeling you have to provide it. Then the model should be trained by using this data, resulting in a model that attempts to predict whether new mail is a spam or not. So using that particular data. So this is the next step we called evaluating the model. So here we have go with the test data, okay, testing data. So model evaluation is a method of accessing the correctness of model on testing data. The test data consists of data points that have not been seen by the model before. Okay, so as you see, we split the data into training and testing set. So here we use the testing set, not training data set. There are two methods of evaluating the model that's called holdout and cross-validations. To avoid overfitting, both models use a test set not seen by the model to evaluate model performance. These techniques or methods we'll see in the further lectures. Now, once you have got that particular data model, now next step is performance tuning. Each model has its own set of features or parameters that needs to be tuned to get optimal output. So for every model, your goal is to minimize the error, okay, or say outliers. Say that you have to predict prediction as close as possible to the accurate values. So to give that accurate values, we have different approaches. ठीक है तो this one is to of the core say that major objective is the hyperparameter tuning. So there are three approaches of hyperparameter, that is manual search, random search, and grid search. Okay, so through which we can tune the overall model. And after what tuning, what is the output of the performance tuning? We will get the more accurate results. Okay, the efficiency of model will increases. Now the last step is the prediction, where we refer to output of the algorithm after it can be trained on a historical data set. So here the once we have the data, we train the model, machine learning model, and then we evaluate, we predict. Now what is prediction? We have to give a new input to the machine learning model, and it will predict using that previous learning, okay, previous experience, and it will give the result. So machine learning has two main goals: prediction and inference. After you have a model, you can use that model to generate predictions, which means to give your model the inputs it has been never seen before and obtain the answer the model has predicted. In addition, to make prediction on new data, you can use machine learning models to better understand the relationship between the input features and the output target, that is label, okay, which is known as inference, So this is the relationship between the input feature and the label, the output target, which is refers to the inference. So this is how we can find out the predictions. So here we can discuss the various applications. So I already discussed various applications within the steps. These are some of the smart traffic alert systems. Okay, so, social media, in which post or which image or video will you have to show. So according to the interest of the customer, the machine learning models will predict that particular image or shows to the customer. Transportation and commuting, product recommendations. Uh, in product recommendations, we have uh, you if you search a particular pen drive in your application of shopping application, then next 2 or 3 days you will get the ads of pen drives in anywhere, okay, in any particular applications. So this is how we can give that. Or also according to their previous research, the search in the applications, it will also give the recommendation to the products also. Virtual personal assistants, various chatbots or AI bots are available. Self-driving cars using different kind of sensors, it will decide rather to drive or not. Dynamic pricing, Google Translate, it is a uh, language processing. Okay, online video streaming, fraud detection. One of the fraud detection is spam or not spam. We can already discuss in the previous slide. So these are some of the applications of machine learning. Okay, where we can use the machine learning algorithms. So thank you, and we'll see you in the next video.